All right, thanks everybody for joining today. We have a topic that we've presented before, but we're going to be offering a little bit of an update on status and leave some time for questions at the end. Uh, Brian Tierney and Doug Southworth from TACC are going to be talking a little bit about NetSage. So, Doug, I'll hand it over to you if you want to share and get started.
All right, thank you very much. Go ahead and bring this up. Okay, so we're going to take a quick walk through NetSage today, both for people who aren't familiar with it, just kind of an overview of what NetSage is and does and how it works. And then we're going to launch into, for those of you who are familiar, what we've done recently in terms of NetSage updates and a little bit of talk about some maybe future goals we have for NetSage moving forward. So NetSage has been around now in various forms for 8 or 9 years. Basically, was originally a NSF-funded collaboration between IU, LBNL, and University of Hawaii. And it was born out of a desire to be able to see and understand traffic utilization across IRNC links. So at the time, we were with the International Networks at Indiana University group that was, responsible for a couple of transatlantic links, and we wanted to know specifically how they were being used and be able to show the NSF how they were being used. And so at the time, there really wasn't a particularly good way to look at flow data, so we came up with what we'll call at the time a new and novel way to understand flow data. And in the process of doing so, we thought we have this network data. What's that going to look like? How are we going to present that in an interesting way? Because collecting data is easy, but showing data in a useful format is a little bit trickier. So what we came up with was an idea of, as opposed to saying, here's SNMP data, here is flow data, we came up with an idea of what kind of questions would people ask about this data if they knew it was available. And so we decided on a question-based navigation system that kind of presented interesting opportunities to jump through that data in ways that, we'll say not strictly technical people would be interested in. Um, Network engineers know exactly what they're looking for, but the rest, we'll call it the 80%, don't necessarily know what kind of questions you could ask. So by presenting it this way, we've been able to come up with human readable summaries and patterns that even if you're not a network engineer, you usually look through and find things that make sense, what you're expecting to see, or maybe things that don't. So we've got some examples from a couple of our different dashboards all mashed into one here. For instance, this first one here is SNMP data. And so usually you see spikes and changes over time and it looks pseudo-random, but all of a sudden we see this little pattern here that pops up. Well, that's kind of an interesting pattern. It's very regular. What's going on there? Is that something I should be looking at or something I should be concerned with? Another one where we're looking at very specific flow information here. This is a very specific flow between two different institutions on the other side of the Pacific. But we do notice that the sensor that's picking this up is in Los Angeles. So this flow data is coming from Singapore and heading to Taiwan via Los Angeles, which I'm not really good in geography. It was not my strong suit when I was in high school, but I am pretty sure that that is not the shortest route between those countries. So that was one that we ended up looking into. Or just more generic questions like we've done 2,700 flows, almost 2,800, 2.7 terabytes worth of volume, but the average rate is only 4.6 megabits, sorry. So why is that so slow? Is that something we should be looking at? So the architecture that makes this all happen is I've kind of revamped this because it's changed a little bit over time. But basically, we have we'll say two halves of it. There's a half that happens at the provider site, and there's a half that happens at TACC. So we collect flow data, Globus data, and SNMP data primarily. There's other kinds of data that we can ingest, but those are basically our bread and butter. So at the provider site is where we grab the flow data and or Globus data, if that's the kind of thing that we're ingesting. And it goes through a Docker pipeline that basically runs through multiple different stages. But First thing we do is we get rid of flows that are smaller than 10 megabytes in size because we are looking at elephant flows. We're interested in large flows and the total volume. We've actually done 10 megs is the standard that we decided on a while ago. We've actually been doing some experimentation here at TACC recently, and we found that even lowering that threshold to 1 megabyte meant that we discarded the vast majority of flows, but kept most of the volume. I can't remember the numbers off the top of my head, but it was something on the order of we were throwing away 80 to 90% of the number of flows, but we were keeping 97% plus of the total volume. So we're not interested in DNS traffic, small stuff like that. We do SciReg tagging. So the science registry is something that Brian's going to talk about here in a little bit, but we do flow data enrichment with tags from the science registry. If there's nothing in the science registry that is already been submitted, then we just go to a more generic internet-based CADA database to put a name to that IP address. And then we stitch together long duration flows. Flows come in 5-minute intervals. That's the collection interval that we're running. And if that flow exceeds that 5-minute barrier, then we want to stitch it together so we understand what the entire flow looks like end to end. We do have a 24-hour cutoff though. So if it's a very, very long flow, you'll see it just kind of end at that 24-hour mark and then start again. And then the last stage we do is de-identification. So we take off the low order bits. So IPv4, that's going to bring it down to a /24, or for IPv6, it's a /64. So all this happens at the provider site. So if you notice on the right side at TACC, when it goes into our Elastic database, we never have the full IP address. It never even comes to TACC. It is de-identified at the customer site. So all of that gets stored in Elastic, and you'll notice that SNMP data comes from the provider site but does not go through our ingest pipeline. We found for a variety of reasons it was easier to handle SNMP ingest at TACC, although as you know, SNMP data is pretty there's really no PII there, right? It's port counters and that sort of thing. So there's nothing really de-identification wise we're interested in doing there. So we ingest that directly at TACC. It also gets stored in Elastic. And then the final phase is we visualize all this data in our Grafana dashboards. So Globus dashboards are something I mentioned a couple times, and this is a recent addition to NetSage. About 2 years ago or so, we went to Globus and said, hey, we'd like to take a crack at visualizing Globus data. And we were actually able to come up with a workflow where they were sending us task data, and the format it comes out in is actually very similar to kind of NetFlow anyway. So with just a little bit of manipulation on our end, we were able to take the Globus format, make it look like it was flow data by just running it through a Python script that Brian wrote, and then feed it into our already existing NetSage pipeline. And it basically just worked. There was not a whole lot of manipulation we had to do. There were a couple, very small hurdles that we had to get across, but nothing that was a deal breaker. So we were able to start visualizing data last year, and we actually were able to grab back data from them going back to July of 2023. So there's actually a pretty decent archive of Globus data going back a couple years at this point. So at this point, we're going to get into the global science registry piece of this, and this is where Brian has been doing kind of the lion's share of his work. So I'm going to let him jump in here on the mic and talk about the work he's been doing.
Sure, Doug, thanks. Yeah, so the science registry was part of NetSage from day one. It was actually a concept that even existed before the NetSage project, where the whole notion is we build up a database of subnets and mapping them to interesting resources in the R&E space. And we collect that data just partly from talking to people and partly from looking at web pages and doing DNS lookups and figuring out what's going on. But the old version had gotten a bit out of date and a bit hard to maintain. So Doug, you can go ahead and move to the next slide. We made a number of changes starting, I guess it was roughly a year ago. that basically it was completely refactored and simplified, and now it's just a very simple hand editable JSON file, although we have some scripts to make it, you don't have to edit it by hand. Um, and then the JSON is converted to an MMDB database format. That was a database format that MaxMind created. It's an open source um, tool. There's some Go code, a Go library that lets you build these MMDB databases. We went through, deleted everything that we appeared to be obsolete, and and then basically just started digging around in NetSage and identifying some of the highest volume flows and added additional resources to the science registry. We encourage you all, anybody who knows about what resources are at your sites or at your customer sites, to take a look and see if it looks accurate, see if there's anything missing. But basically, it's very, very simple. We just need the subnet, the organization name, and the resource name. It's just those three things are the only things that are really important in the science registry. Um, it's still, I mean, by definition, these kind of databases become out of date relatively quickly.
Pretty
Um,
much when we publish them.
yeah, but I think it's better now than it was a year ago. And with your help, it we can help keep it up to date, and it's still we think it's quite useful. Doug will demonstrate some of the new resource views in the dashboard here in a minute. Um, Next slide.
There you go.
And then the other thing we added in the last few months is this notion of communities. So we are tagging various subnets as part of a community. And the communities we currently support are the NSF access sites, the NSF supercomputer sites, all DOE sites, they're a community. And then we've worked with UT Systems, that's University of Texas. TACC is based in Texas, so they wanted to tag their stuff. And then some of the other regionals that we've got is Scenic, iLight, Southern Crossroads, FRGP, Front Ridge Gingapop, New Jersey Edge, et cetera. Learn is also in Texas. So we were able to build up these collections of subnets. In some cases, people from these regional networks sent us the data. In some cases, we just found their website listing all their members, and we scraped the website and then ran that information through a very, very useful tool, bgp.he.net. I don't, if you're not familiar with it, Hurricane Electric provides this great tool for figuring out what subnets belong to who. Um, and so if you want to see what we have for your network, you can, there's the URL is there, downloads.netsage.io/communities. And we would find it very helpful if you're familiar with your own community, if you can skim that over and see if we're missing anything or if there's any problems there. Next slide. Yeah, so this is a map of GPN, Great Plains Network. Here's the various portals that we currently support. Um, that's the list of regionals, and then we have one for TACC and then one for access as well. So the demo that Doug's about to give is the newest version of the Grafana code, which currently is only running on the tac.netsage.io page. So if Doug shows you something and then you go to, for example, frgp.netsage.io and say, why does this look so different? It's because we haven't updated it yet, and we will do that next week. So wait a week before expecting all the cool stuff we're about to show you to be available at anything other than tac.netsage.io. Next slide. Um, Doug, you want to jump back in? I mean, you sort of talked about this one already.
Yeah, so this is a question we get asked a lot, which is, what are you doing to protect the data that we're sending you, or how is it okay that we're sending you flow data? Because flow data is fairly innocuous anyways, but you definitely can make inferences about what's happening on a network and potentially, PII type of stuff. So we've taken great pains to make sure that there is no PII stored in NetSage. Like I said, the de-identification happens at the customer site. TACC never has access to the full IP, which people like that idea. And then as soon as they see NetSage data, they will, well, I want to know what that IP address is, inevitably. But we don't have it. We never have it. And we do have a fully fleshed out data privacy policy that is available there if you would like to take a peek. And of course, these slides will be made available as well at the end, so you don't have to memorize all of these links as we're talking about them. So now we're going to do the thing that you're absolutely not supposed to do, which is a live demo. Um, so when you go to any of the different the different NetSage instances, you'll be greeted with a very basic page that looks like this. And there'll be a few variations on it depending on the type of data that your institution is giving out. For instance, TACC has SNMP data that we're including. So if I scroll down a little bit, there's SNMP data about TACC's links, and there are a couple of SNMP links up here if we want to take a look at those. And we're in the process of kind of refactoring some of these, but we'll take just a real quick look at what you can expect to see on an SNMP page. So again, we're not collecting real in-depth SNMP information here. You know, there are thousands and thousands and thousands of different metrics you can connect or collect, but we're basically looking at bytes in and out and min and max values. So for different interfaces, you can basically browse through if your institution is sending this kind of data. So it allows you to at least, understand patterns and that sort of very odd usage pattern, maybe kind of hone in on a time range where you found something interesting and then look at, flow data in that same time range. The home button up here will always take you back home, as one might think. So we're going to go ahead and start off taking a look at flow data. So the top landing page here is just what are the top sources and destination of flows. So this is going to be for the entire network, the entire site that you're looking at. So if you're looking at Southern Crossroads or you're looking at Learn, this is going to be basically all of the data they are collecting across all of the different regional locations. In our case, since we're looking at TACC data, it's literally just the TACC exit router. TACC is a little bit unique in NetSage land because normally we're collecting network data from networks that, we're collecting from the edges. Whereas at TACC, we're collecting, we're an endpoint, we're not a network. So the data is a little bit different, but the process of it is basically the same. So the new things that this page would look familiar if you've been on NetSage at all in the past 5 or 6 years. One of the new things that we're doing though, or a couple of the new things that Brian was talking about was this idea of resources and communities. If I flip this toggle to yes, we'll still see our volume by organization, but now we have it broken down by resource as well. So as opposed to just looking at TACC as a whole, we can now see TACC shows up several times over here as an organization, but we can look at the individual resource utilization. And again, this is all fed by data from the science registry. So since we're at TACC, we can make sure that our registry piece of it is up to date. But we do have a lot of other information in here from other institutions that they've submitted as well. So doing that allows you to see both by volume and rate, by source, and in this case, destination down here. And then we also have another couple of ways to visualize this data. The top pairs for the selected time range up here. And if you're a chart person, we have it presented in a chart format. If you're more of a visual person, we've got it presented in a visual format down here. And that's one of the things that NetSage you'll find across a lot of the pages is we have similar information, or in some cases even the same information presented in different formats because it resonates differently with different types of thought patterns of different people. So this usually on a network looks a little more chaotic because TACC is an endpoint, obviously. We tend to have graphs that just look like a nice two-way hash. But again, we're presenting that by organization here, and the new addition we've made down here, if you scroll down, the same two types of charts, but now they're presented by resource as opposed to strictly by organization. And this spaghetti mess down here is a little bit more what you would see with flow data in a network type of setting. Because we've got this broken into resources, it has multiple endpoints now. And then there's just some very high range information at the bottom, total number of flows collected, the largest, the fastest, what ports were in use, that sort of information. So navigation wise, if we were to be interested, let's say we notice NERSC is number 3 here. If I click on NERSC, that's going to take me to our by organization page, and you can see it's already passed organization over. And of course, because TACC is the endpoint, it's the only destination organization. If this, again, was a larger network, you'd see quite a few different destination organizations there. I'm going to step back. So, well, let's see. So you can see it automatically populated the organization, but no other data. However, if I go back and I click on, so NERSC, the resource that was sharing that data was their data transfer nodes. If I click on this link instead, that is going to populate the resource information as well. So all of the linking that you see in NetSage, if you click on a link that has more specific information, it will pass that more specific information to the following page. So we're going to go back one more time just to our top sources and destinations. We'll stay at this top level because I also want to show off the concept of communities. So right now we are looking at all of the communities and we have our resources enabled. I'm going to pick on DOE because we have the most complete list of DOE sites. If I select that, you'll now notice that all of the endpoints look like DOE sites, which is exactly what we were expecting. So Fermilab, Lawrence Berkeley, Oak Ridge, NERSC. So this is a way to visualize your data by a specific collection of institutions, whether that's a regional network that's been defined or something like the Department of Energy or UT Systems, which spans the state, and we want to be able to see what UT system data looks like as a whole. So we consider those groupings of different institutions to be communities. So if you're interested in that kind of specific data, the toggles all work together. You can have no resources and just communities if you want to see that. So now you can see data totals as a whole as opposed to by resource. You can mix and match this basically however you like. So we'll walk through the navigation from the general to the specific. Again, let's go ahead and turn our resources back on. And let's pick on Oak Ridge here. They have their leadership class computing facility here. If I click on that as a resource, that takes us again to the by org page. So now instead of all of the different organizations possible, we're limited to just Oak Ridge, and it passed our resource along. So obviously, again, because we're an endpoint, we only have one option here. But if I click on this link in this table here at TACC, that is going to move us forward into an individual flows page. So now we are looking at Oak Ridge as our source, TACC as our destination. We can select resources. It is context sensitive. So if you want to look at a specific Oak Ridge resource, or in our case on this side, a specific TACC resource, you can select those as well. You can filter by subnet if you, again, not by IP address because we de-identify down to the last low order bits, but if you want to look at a specific subnet, you do have the ability to just type in and filter. And if we had more than one sensor, you could pick that as well. Test traffic is per sonar traffic by and large, and that gets tagged by port numbers. So if it's coming from 5200 or 5201, which are the iPerf ports, turning that off basically eliminates most of each per sonar traffic we see out there. So now we can get a sense of what individual flow data looks like between institutions on this table down here. And if we had questions about a specific flow that we saw, we're just going to pick this guy here. This page here is the most detailed page that we have in NetSage. This is basically all of the data that we've collected. The flow data records have more data than this, but it's effectively the most interesting information that we have, the most complete set of information we have. We can tell what data source the information came from, whether it was the science registry, or if it didn't come from the science registry, it came from MaxMind or CADA. That would be displayed there instead. We can see if we have a science discipline attached to it or not, latitude and longitude numbers, and then our community information, this is a new thing that we've put in as well. We've broken out the community into a separate panel down here because by default, this panel here was only showing the first one that it came across, and some things like TACC are a member of multiple communities. So if you have any question about how a specific flow is being categorized, jumping down to this individual level flow page is going to be the one that gives you the answers about why things were tagged the way they were tagged. So that's kind of a quick overview of how the new functionality works in NetSage. We're going to go back up a few levels here. I'm going to get rid of this and this, and we'll go back to the home page for a second. We do have other pages as well. There is top flows by country. So if you're interested in this from more of a international standpoint, you can look at this by community as well. So again, if we pick on DOE, not surprisingly, all the DOE labs are in the United States. But again, if this was part of a larger network, you may have data that's going overseas from one of your institutions, and if you can use this to kind of sort and sift and see what other types of countries you're doing large amounts of volume with. Science discipline, this is fed basically exclusively by the science registry. So the information in here is as accurate as whatever was submitted to us. We can still select a specific organization, but now we have the ability to select a specific science discipline. And so the default here is high energy physics because that one shows up most places. But if you have some other type of science that you're interested in looking at, maybe if we grab all the geos here, we'll see some interesting data there. So there's a big push for geoscience here for the third. It's kind of interesting. So again, if there's specific science domains that we're aware of associated with specific projects, then you can come in here and find those. And again, you can sort by community as well. One other similar type of page we have, which is by project, is where we've made an attempt with the Science Registry to group together resources for specific projects like Atlas or CMS or the IceCube project. And so I'm going to widen out the time range on this a little bit because the last week typically isn't interesting, but the last, let's say 90 days usually yields some more interesting information about which resources are being used. So, for example, Atlas Tier 2 data from U Chicago is actually hitting a variety of different TACC resources. And I think you find the same is true if you look at something like CMS. Now we have kind of a variety of different sources and destinations. And again, we present this data both in chart format and in a more visual graphic format. And so we have also some heat maps that are of interest because they show you by volume and rate when the most intense transfers were. So this dark square here means that a whole lot of data happened, 8.8 terabytes in that 1 hour window there. The caveat there is it's not really a 1 hour window, it's when the flow ended. So that could have been an 8 hour long flow, but that's specifically when it ended. So it's a little bit it doesn't mean it happened necessarily within that window, but it is an interesting insight. Sometimes you pick up patterns of, man, we have large flows or large amounts of transfers that always typically happen in these time ranges. So this is more for pattern finding than anything else. And then we've got endpoint summaries and again, just sensor observations at the bottom. Let's see. Top talkers over time is always kind of an interesting one where the default view is 3 months. And this one, once it populates, shows you by source and destination who the top talkers were for a specific organization. So obviously TACC is always going to be the top talker at TACC. There's no surprises there. But if we looked at something like Purdue University, over the past 3 months, we haven't done a lot of business with them, but they, in the past few, let's based on this graph, the past couple weeks, have transferred quite a bit of data over here. So it's kind of interesting to see them pop up out of nowhere. So that's maybe a clue that project is kicked off, or maybe there's some sort of data reshuffling that's going on. UMin looks like they're fairly consistent. They're there and then they're gone. SDSC, kind of there and gone. A little bit of an interesting usage pattern there. But you can see the value of being able to visualize this data over time to understand larger scale patterns. And once again, we've moved our community information over here as well. So if we pick on FRGP, we now have front range gigapop resources to TACC, and we can see these graphs have updated accordingly for the different resources that are associated with FRGP. And then kind of lastly, we have just a flow data summary statistics. So if we just wanted to get a 10,000 foot view of transfers here at TACC, this is what it looks like. So we can see source and destination organizations, ASN numbers, different countries. We don't have IPv6 turned on here at TACC. That's coming, but that's pretty evident by the 0 over here. And then how many flows were tagged in the science registry and whether that was tagged on one end or both ends. And we have some summary data that we've added. These two panels here for communities. So we can just take a look at, again, kind of a high level view of which communities are we doing the most business with, and which ones are we are not particularly moving a lot of data. Does that mean that we don't do a lot of business with Ornet, or does it mean that they have resources that need to be contributed to the science registry? That's a lot of times how we use these pages, is to understand maybe there's something that we need to look at in terms of science registry contributions. But the low number of flows here, only 63, says we probably just don't do a whole lot of business with them, at least in this time period. The good news is the communities are populating nicely. None was a top talker for the first month, but now it's starting to move down the list as we're getting more and more information submitted. These top protocols by count that you saw on some of the other pages, we've also been asked what they look like by volume, so we've included that information here. The source and destination countries are really just there for reporting purposes, but if you do have, if you want an individual list of which countries are being used or utilized as a source or a sink of data, that's where that data is going to come from. And then again, a different look at the science registry. We have these panels at the bottom that are the top sources and destinations that we didn't find in the science registry. And so if we see a commercial entity, we're not going to add that in. But if we do see we've got a couple of different entities here that have moved a lot of data that apparently there is no match for a specific IP range, that's probably something we want to look at and add and include. So these all carry over to the Globus dashboards as well. There's a couple different options at the top. You'll notice, on the home page here, there's Globus data. This is the data that we're getting directly from Globus, and this is included on all of the different NetSage portals. So if you go to the SOX portal, if you go to the Learn portal, you'll have this Globus, what we lovingly call the mothership. You'll have access to all of that data. So I backed this out to a 90-day view. The toggles at the top are a little bit different. Obviously, we don't have a sensor that we need to pick. And the resource in the community, again, they work just like they do on the flow page. If I turn on show my resources, then here's the resources that specifically are transferring Globus data. And then the community toggles still work as well. So if I pick on DOE one more time, then now we're looking at Globus transfers between DOE sites and what resources are being used to make those transfers. There is one more toggle that I'll turn these back off for a second. That doesn't occur in the flow data side, which is display private tasks. Globus has some industry partners that do not want their display, basically a display of what kind of data they're transferring. And usually those partners are kind of outside the scope of R&E anyways, but we do at times want to understand the total volume that is transferred between every Globus endpoint. So we've included those. By default, it's turned off. But if I turn them on, you'll see this private organization pop up. And so we're using that exclusively just for data totals, but there's no information. The IP address have all been completely masked as just quad 255. And there's no specific information about those other than the totals themselves. So by default, we leave that off, and it's for the purposes of an R&E, it's not particularly useful information. But the navigation works basically exactly the same as it did before. I can pick a specific resource and it'll carry me to the next page. And if I want to look at, let's turn on resources again over here. So TACC other is what you might expect. It's resources that are not specific to a large project that we have, but we have a lot of irons in the fire, and sometimes it doesn't make sense to categorize all of them. But we can look at those specific resources on a level here. So let's take a look at Stampede. And that's going to bring us to an individual task page, which looks a lot like the individual flow page. And now we're looking at NERSC to TACC to Stampede specifically, and we're seeing what those kind of transfers look like. And it looks like there's a lot of very regular, similarly sized transfers, all with the same amount of files. So that's probably some sort of batch job that gets kicked off every so often. And again, if you want very specific type of information about a specific task, it'll bring you to this page that gives you, again, basically everything we know about that specific task. So that's effectively the kind of the tour here in terms of NetSage functionality and how we've included these new ways to group by task and resource that didn't exist before. At this point, I'll go ahead and open it up. If there's anything people want to see specifically, if there's any questions you have about, kind of our process, how we do specific things, I can take some questions here, and then I'll take a couple minutes at the end and I'll talk about kind of next steps for NetSage. But while this is fresh in your mind, I'll open up the floor a little bit.
All right, I've unmuted everybody. So if you want to raise your hand or just shout out a question for Doug, certainly do so.
Yep. If anybody has any questions about their particular site, we could use that as an example if anybody wants to be a guinea pig.
Step right up. Stun silence is always my favorite, though.
I'll give people a moment to sort of ruminate on it. Otherwise, I think I'll just call on somebody because that's always fun too.
Well, while they're ruminating, I'll let them think about that for just a second. Let's go ahead and just get through the kind of the last what's next steps for NetSage. The Metronova initiative is something that's new in this space. It's a consortium that's kind of patterned after Personar, which I believe everybody in this room is probably familiar with, made up of ESNet, Geant, IU, I2, and TACC. And basically, the process that was that created NetSage at the time was new and novel, and to a certain extent still was when ESNet Stardust was born. But being able to collect network data and visualize it in Grafana is not necessarily new anymore, but there's still a lot of hurdles to be able to do that. And so we wanted to be able to form this consortium that can help people understand how to visualize that data, kind of engage in best practices, have an understanding of the performance implications of using different types of database structures. There's a lot of guesswork that's still involved in that. If you're just starting out from scratch, we hope to be able to answer a lot of those questions. Metronova is actually going to be producing a full software stack that you can reproduce at your home institution. So we're not there yet. It's still in the very nascent stages, but that is one of the work products we will be churning out. Does that mean that NetSage is going to go away? No, absolutely not. NetSage will continue on doing what it does best. But there will be some code sharing and alignment efforts between the NetSage project and Metronova, where our ingest pipeline, already looks similar to the one Metronova is going to be using. ESNet's Stardust actually has a very similar structure as well. Stardust was kind of built out of NetSage. We call them cousins, and we've done some work in the past to kind of keep them aligned in certain strategic areas. But moving forward, the goal is to reuse some of this specific ingest infrastructure so that we're not all inventing slightly different wheels that have a lot of the same characteristics. Nobody needs to be putting the development cycles into duplicating effort. And there's also a concept in Metronova of federated data, which is data that has been vetted by your institution, is okay to share, and there's a possibility that we will be contributing NetSage data to the kind of the Metronova Federation once that's set up. So as that effort continues to grow and to develop, there will be more and more alignment between these projects, but NetSage is not going anywhere. And the last one is really kind of an AI pipe dream that I threw in here. This is kind of a, if we can find the money and the time, everybody's pressed for both of those things. But there is a case to be made for AI integration in this space. And I know AI sounds like a buzzword that, everybody's expected to put AI into their products, but there are some interesting use cases where we can't possibly anticipate every question you would want to ask about this data. But like, for instance, let's say that you looked at a Globus transfer, a Globus task, which is a collection of flows, and you wanted to see the individual flow data. There's no super convenient way to be able to cross-reference that data from a Grafana dashboard standpoint, but AI is very good at this sort of thing, where you could, in theory, be able to ask AI, hey, given this Globus task with these specific endpoints and IP ranges, could you show me associated flow data that matches that in the same time range? And then you could make your own inferences about whether that flow data actually accurately represented that transfer or not. So there's a potential use case here for us being able to give you basic questions and present data the way we always have, but then maybe have some sort of AI integration that if you had a very specific question, it might be able to mine through that data and give you a more specific answer. We do tend to find that we get these one-off questions that we can't build a dashboard around. We don't have the development cycles to answer that one question, but this would be good at that sort of data correlation. So those are kind of the two things that the AI integration is, I put in parentheses pipe dream there because it would be really nice. I can't say that we have a roadmap for that, but it is kind of rattling around in my brain. So we'll see where that ends up. And that definitely does bring us to the end of our presentation here. Again, NetSage is a free resource. TACC is continuing to develop NetSage under LCCF funds, so it is not going anywhere. And it's not a replacement for your own network analysis tools. It is designed to be able to give you high-level overviews and recognizable patterns that you can then take back to your institution and say, I think we need to drill in on this a little bit deeper. Here's the endpoints in question. Here are the time ranges in question. Let's use our own tools that we already have on campus to burrow in a little deeper, assuming we saw a performance problem or something along those lines. But the NetSage project as a whole is healthy, and we're making a lot of good headway, and we're going to continue to do so for as long as we are able to.
All right. Well, thank you, Doug and Brian. The mics are still unmuted, so if anybody does have a question and wants to raise their hand, please do so, or you can still ask in the chat room. If you did want to pull back up the interface, Doug, we can name somebody on the call if you wanted to look at their data.
Perfect.
I'll never resist calling out Scott and Matt from NCAR/Front Range if they'd be willing to abide in asking some questions about their data sets.
Yeah, I thought you might do that.
You
Um,
know me too well, Scott.
yeah. No, if we could get a tour of our own, yeah, I clicked on a little bit, but it looked like the as they said, it's the new interface isn't quite ready for front range gigapop, it looks like.
No, we can at least look at flows between TACC and front ridge gigapop sites,
Yeah,
the new
absolutely.
interface.
So from an organizational level, do we want to take a look at? I mean, we can.
Well, you could start with just bringing up the community, Doug.
Well, that's true. That's going to be back at this level. So yeah, if we switch our community out here, let's just bring up FRGP. And yeah, we actually have a fair amount of data in there. So you'll notice the source and if the resource matches the organization, that means we don't have anything specific in the science registry. But we did have to populate the resource with something. We don't, for a variety of technical reasons, having it be blank is not useful to us. But if you see something down here like Glade storage, then that means that we have something in the science registry there.
Yeah, and I recognize that name. That is our big bunch of disk
All right,
up in the Wyoming Supercomputing Center.
okay. So we've in the past week we've done a little business. Let's widen this out just for giggles. Let's go back a month.
Ooh,
So
look
yeah,
at
we moved some data with you.
Yeah.
that. And how about can you get a average rate for that transfer, Doug?
Yeah, actually, if we look at our average
There
is
you go.
83 megabits, which is again the caveat here is flow data is weird, right? Because you have a variety of different use cases and parallel streams and things like that. So if we wanted a better understanding of why these numbers look the way they would, if we click on TACC, that's going to bring us to our individual flows, and that will give us kind of an average rate, and we can look at it by total volume. That's our default. But if we look at this by rate, we can kind of see the spread a little bit. Um, and you tend to come up with interesting groupings of, like clearly here, these are all getting kicked off within a second of each other. This is likely a large multi-stream uh, Globus transfer. In fact, it looks like there's, I don't know, man, we're still going. What's that, like 16-ish parallel streams? So all of a sudden, 161 megabit doesn't look as bad when you figure that's been parallelized, 16 times. And so I do give people caveats about the data. You definitely want to understand their performance implications, but the fact that they all have the same timestamp, they all have roughly the same duration, that's a pretty good indication that that is one large parallelized transfer.
And you might be able to find that in the Globus page too.
Probably so. What is this? March 12th? Around noonish. So, out of curiosity, let's go to. We'll just kind of manually fill this in real quick, but we'll put it in appropriate time range here. So we said that was in the neighborhood of 12. So let's just, for giggles, we'll give it a little breathing room on either side. And TACC destination org was going to be NCAR. No, don't do that. Okay. So sure enough, that's our timestamp. So we have a Globus transfer there. So the
And those
combined
rates
rate,
are, yeah, quite respectable rates.
yeah, that's nothing to sneeze at right there. So that's the kind of thing we're working on. How do we correlate that a little bit better? We have some ideas, but there's no there's no real easy answer to how can you completely. We don't want to put information out there that's so subject to interpretation that we say if you click on this, it will absolutely show you this because that's not necessarily the case. You have to be able to correlate and infer a little bit. But yeah, that's a really solid transfer.
But and that I see the duration is 1552. Is that like 16 hours?
Yes.
Yep.
Yep.
Yeah,
Wow.
and it's 15,000 files.
Yeah.
Yeah.
Wow.
So if we let's go take the information here, one step further and take a look. Yeah. So that's the pattern we expect. You've got 443 on one end, which is Globus, and then your ephemeral port on the other side. So, um, yeah, we were just trucking some data with you.
That makes sense. Yeah, it's impressive to see how much data moves and you don't need to worry about it.
Yeah, exactly. And so if you look, if you do see individual flow information though that you don't see those kind of correlations where, man, it's just one individual flow and the performance is really poor, then sometimes jumping in here can be kind of useful because you can look at the protocol being used. And if it's FTP or SCP, maybe that's something that could be, maybe Globus could help that out, or maybe it's just intentional. We actually had an interesting use case once with NASA Earth rotation information, where flows one direction were fairly respectable and flows the other direction were terrible. They were very, very long, very, very slow flows. And we talked to NASA about it, and they said, well, yeah, it's Earth rotation information. So basically, we have larger amounts of data that go one direction infrequently, but then it's basically streaming telemetry going back the other time. So a long duration, very slow flow is kind of what we were expecting there.
Hmm.
But we that was an interesting pattern to us, and we got an answer about it as opposed to just assuming the performance was bad. It allowed us to ask an intelligent question as opposed to basically just throwing caution to the wind and assuming something was wrong.
Somebody had raised a hand.
I think they may have fat fingered it when they were trying to do a thumbs up.
Oh, okay.
So yeah, that's an interesting one there. That's kind of a fun find. And if you spend any time pawing around in NetSage, you find either really, performance is good, which we're doing a lot of transfers and a lot of data movement. It's as expected, or you find why is that so darn terrible? And those are kind of interesting to find as well. And sometimes it's a routing issue, and sometimes it's, or it's always the MTU, right? But at least here you've got the kind of the global perspective to find something like that. I'm just curious if we go down the list a little bit. Again, I want to widen this window out.
So Scott does have a follow-up. What are the five things in the five tuple hash?
Source and destination port, source and destination IP, and protocol. So it's just your standard kind of five tuple that all of those are based on. We do create a unique flow ID in NetSage that's kind of a five tuple plus time because the five tuple there that hash can be replicated, right? If you have the same port and destination. I'm sorry, it's ports, source port, destination port, IP address, and then timestamp. So you can actually duplicate that, right? Like you can actually have, an instance where you have multiples that match that, and you'll get the same hash. So for NetSage's purposes in the pipeline, we also kind of put timestamp in with that, so we have a little bit better idea what we're looking at. I was just kind of curious to go down the page here a little bit and just see if there's anything. Yeah, let's look by rate here, maybe average rate, to see if there's something that's really crawling that would be interesting to take a peek at. Well, we already know what that is. Do, 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 do. Well, this one looks a little interesting.
Yeah, derecho is down for repairs this week. Or well, there's power maintenance going on. So
Okay. Yep, the flows we did get weren't. Let's just click on it. It might be nothing, but it might be something interesting too. You never know. That's the discovery portion of the program, right? Yeah. Wow, that's a lot
Yeah,
of
those are pretty
very slow.
crafty, but who knows? I mean, the thing is,
Yeah,
especially with Globus, people run it on their laptop on Wi-Fi, right? So you never know.
it's true. Kind of grouping these by similar rates, though, they definitely look like they're individual flows spread out across a wide time range. So that's one, I mean, it may be functioning as intended. If you look, these are all 24 hours. And remember, I said we truncate flows, we kill them at 24 hours. So
You know
this
what
has
that
been a,
might be? That might be the flow data leaving the front range gigapop going to TACC.
yeah.
I recognize the 192.43.217. That's the front range gigapop um, /24.
Okay. There you go. That
And
could very well be it.
those data sets are that big? I guess maybe they could be.
FRGP is one of our biggest
Yeah.
flow data contributors, actually. Yeah. So I,
And the duration, look at the durations. They're all a
yeah,
day.
they're all getting capped at a day. So basically, it's one really really long flow that just keeps getting chopped into 24-hour segments because that's when
Hmm.
we drop the hammer on it.
Yep.
So
Yeah.
yeah,
Interesting what you find.
yeah,
Yep.
you just sometimes we find per sonar testing. You'll find patterns in here that are very clearly per sonar testing, and sometimes it's happening very, very frequently and at, to places you wouldn't expect. So you find somebody that turned up a test a year ago and didn't remember to turn it back off, and they've been hammering your per sonar node every 15 minutes instead of, 4 times a day, which is more standard. So it's interesting to find those kind of things in here.
Yeah, I've definitely seen that behavior.
All right. Well, we're at the top of the hour here. So thank you again, Doug and Brian, for going through this. Make sure you shoot me your slides. I'll get those posted along with the video. We are going to be on a break for a couple weeks. The next talk is going to be June 27th, and that's going to be with a couple of folks from SDSC, and they are going to be going over some national research platform materials. So it'll be a couple weeks in a row with a break in the middle for the 4th of July. But there'll be several talks that are affiliated with the NRP project. So hope everybody has a good couple of weeks, and we'll see everybody again on June 27th.